Okay, let us make a start. Okay, 2022 October, November, paper 22. State what is meant by work done. Okay, you are supposed to tell me. Yep. Yeah, muted. You're muted.
Yeah, teacher, my connection got something wrong. Okay, product of force and distance.
No, not distant. Distant move in the direction of the force. Okay, you want to get the full mark, you have to make sure you state it correctly.
Or distance, okay.
Right? Distant move in the direction of the force or displacement in the direction of the force. Okay, what's the base unit?
kg meter square, second minus 3.
Right, must show you're working lah. Right, this is your force, mass as acceleration, 10x meter times second. Okay, good. Kilogram meters, 2s minus 3. The maximum useful power, output power of the car traveling on the horizontal road is given by P equals to V cube V, where V is the maximum speed of the car and V is a constant. For the car, P equals to 84 kilowatt plus minus 5%. V is 0.56 plus minus 10% in SI unit. Calculate the value of V.
53 meters per second.
Okay, 53 meter per second. Make sure you show you're working. Important. Determine the absolute uncertainty in the value of V.
9.11.
Follow this equation. Right? Percentage error, Q root is 1/3. And percentage error in V plus percentage error in V. No subtract.
Oh, divide 3.
Divide by 3. Cube root.
Oh, okay,
Cube root.
okay.
If it's cube, then times 3. If it's cube root, then divide by 1/3 or divide by 3. Okay. Any comment?
Oh, no.
A cylindrical balloon is filled with mixed mass of gas. A small block is connected by a string to the balloon as shown in figure 2.1. They are very kind. They are giving you the diagram, not to scale. The block is held on the ground by an external force so that the string is vertical. The density of air surrounding the balloon is 1.2 kilogram meter minus 3. The upthrust acting on the balloon is given 0.071 Newton. The upthrust acting on the string and block is negligible. Use Archimedes principle, calculate the radius of the balloon. Okay, what should I do?
0.14.
It's good to have a picture. Draw the diagram there. What upthrust is given you, weight is given you. Right? Yeah, so the upthrust contributed by the string and the block is visible. So upthrust is due to the balloon. So that one you can get it from your formula sheet. Memorize it, Reggie. Treat rho as E, 0.11 meter. Okay. Total weight of balloon, string and block is 0.053 Newton. The external force holding the block on the ground is removed so that the release block is lifted vertically upwards by the balloon. Calculate the acceleration immediately after it is released. How do I go about that?
The resultant force is the weight minus the upthrust, right?
No, it's not the weight pulling it down. Now when you cut it off, it's the upthrust greater than the weight. That's why it's going to accelerate upwards.
Oh, yeah.
Yeah, I can see from here. Upthrust, that's the weight. So you can calculate the mass first.
Oh, so it's upthrust minus weight.
Upthrust minus weight, oh. But you want to find acceleration, you have to find the mass, oh. So that's why we find the mass first. Then F equals ma. That is greater than that one there. Equals to mass. From here we get the mass. That's acceleration. Okay, 3.3 meter per second square. Can? Anything not clear?
Yeah, it's clear.
Okay. The balloon continues to lift the block. The string breaks as the block is moving vertically upwards with a speed of 1.4 meter per second. After the string break, the detached block briefly continue moving upwards, falling vertically downwards to the ground. The block hits the ground at 3.6 meter per second. Assuming air resistance on the block is negligible, by considering the motion of the block after the string break, calculate the height
Got
of the
0.56.
ground when the string breaks. Say again.
I got 0.56.
Okay. So what is happening will be you won't have a pure question. They will have try to mix two topics. So this is topic one and topic two, dynamics and kinematics. So the block initially will have upwards movement. That's the speed. Then it will decelerate to zero. And after that, moving downwards. And you are given that final velocity. So write down what is given, taking upwards as positive. Right? That's the initial speed. That's acceleration is downwards, negative. Then this is downwards. 3.6 is downwards. So it's 3.6. And choose the equation to use. And calculate the distance. Minus 5.6 meter. Okay.
Yeah.
The string break at time t equals 0. The block hits the ground at time t equals to t. On figure 2.2, sketch the graph to show the variation of velocity of the block with time from t equals 0 to t equals to t. Numerical values are not required, assuming v is positive in the upward direction. So how should the shape look like?
Straight line gradient downwards from v equals 1.4 to v equals minus 3.6.
Okay, that's roughly how the graph will look like. This is the marking scheme. That's the marking scheme. Okay, this is 1.4 initially. That is how you get it. 1.4 here. Then minus 9.81 t. Anything don't agree?
Yeah, I got the same answer.
Okay. make sure the number is correct lah. Right? Where you reach the starting point is correct. There's a second point ending at t equals to 3.6 minus 3.6. Okay, state what is meant by center of gravity of an object.
The point of an object where gravity acts the most on.
Point where the weight of the object is taken to act. Taken to act. Or
All the weight.
the weight of all the weight of an object is taken to act. Okay, uniform beam AB. AB is uniform. Attached to a frictionless hinge as your hinge for a vertical wall at NA. The beam is held so that it is horizontal by a metal wire CD. CD is a metal wire. The beam is of length. Right? The full length is 0.96 meter. Weight 0.23 Newton. The block of weight W rests on the beam at a distance of 0.2 meter from the end. It's given. The wire is attached to the beam at point D, which is a distance 0.4 meter from B. Okay, then from B. The wire exerts a force on the beam of 45 Newton. That's the tension by the wire at an angle of 37 degrees. The beam is in equilibrium. Calculate the vertical component of the force exerted by the wire on the beam.
45 sine 37. 27.
Okay, good. E equals to sine 45 and sine 37, 27 Newton. There's only two significant figures lah, because they use two significant figures. By taking moment about A, calculate the weight of the block.
20 newtons.
Taking clockwise moment, sum of clockwise moment equals to sum of anti-clockwise moment. Clockwise is that weight there at a distance of 5.56 plus 2.0, 0.76. So another clockwise is 23.
Oh, I forgot to plus this one.
Cannot be so careless. So the whole distance you are given is 0.96, so half of it. Half of it.
And teacher, how you know it's 48?
Half of it.
Oh, yeah, it is half. Oh, yeah.
Okay. 0.96 meter. So half of it. The length is half of it from the wall. Careful, cannot be careless. Then this one we have already calculated due to that 45 times that distance there, perpendicular distance. Okay, 27 is obtained from here. There's 27.
Yeah, I got it.
And then 0.56 is that distance there. Taking the vertical component. The hinge exerts a force on the beam at point A. Calculate the horizontal component of this force.
36 newtons.
They just want you to resolve. This is the only one that contributes to the horizontal component. This is 45 cos 37. Okay, Any comment?
Yes.
Okay, then let's carry on. The block is now placed closer to point D. State whether this change will increase, decrease, or have no effect in the tension of the wire.
Increase.
They ask it to state only lah. So decrease clockwise moment. So anti-clockwise moment follows. Okay, now they try to involve another topic. The stress in the wire is given. The wire is now replaced with a second wire that has a radius which is 3 times greater than that of the original wire. Tension in the wire is unchanged. Calculate the stress in the second wire. What you want stress? So look at the stress formula. By d square over 4, 4 go to the top there. So what is constant? Force is the same. Rho d square is a constant. F is a constant. So that is the original one. This is a new one. So you want to find the stress, rho 2. Right? And then take over. Rho is the original one, rho. And then original one is d and 3 times. So this one you take it down there. So can get the answer?
Yes, got it.
Good. A horizontal spring is fixed at one end. A block is pushed against the other end of the spring so that the spring is compressed as shown in figure 4.1. The block is released and accelerates along the horizontal frictionless surface as the spring returns to its original length. Frictionless surface return for you. The block leaves the end of the string with a speed of 2.5, 2.3 meters per second. Yeah, show you. The block has a mass of 250 grams and a spring constant of 420 Newton meter minus 1, assuming the spring always obeys Hooke's law and that all the elastic potential energy of the spring is transferred to the kinetic energy of the block. Calculate the kinetic energy of the block as it leaves the spring.
1.66.
What principle do I use?
Kinetic energy formula.
Basically, this is straightforward mark for you to get lah. Memorize the kinetic energy formula. That's the first part. Then put in your value and calculate. Answer correct, then you get your mark, second mark. Lor. Good. Yeah. Calculate the compression of the spring. So you use elastic potential energy equals to kinetic energy. Lor. Right? Kinetic energy we have calculated. And elastic potential is half kx squared. Calculate out is 0.056 meter. Can agree with me or don't agree?
Yeah, 0.056.
Okay, good.
Yeah, I got it.
After leaving the spring, the block move along the surface until it hits a barrier at a speed of 2.3 meter per second. The block rebounds with a speed of 1.5 and move back along its original path. The block is in contact with the barrier for 0.05686 seconds. Let me just remove some of the hindrance. Change in momentum of the block during the collision. I remember there's a change in direction.
0.95.
So we have to choose the direction is a vector, taking the right as positive. So usually they won't worry about negative lah, because negative shows direction. They didn't ask you for direction. They usually want magnitude lah. If they want direction specifically, they will tell you lah. Negative sign that it goes to the left. No? Okay, good. Average force,
11.
change momentum over time, no? 11 Newton. The maximum compression act of the spring is now varied in order to vary the kinetic energy decay of the block as it leaves the spring, assuming that the elastic potential energy of the spring is always transferred to the kinetic energy of the block. Sketch the graph to show the variation with x of the kinetic energy. Okay, how should the graph look like?
Increasing.
Say again.
Increasing.
How? Straight line, curve.
Curve increasing. Positive gradient increasing
Okay,
from
basically a
origin.
parabola lah. Right? It's a parabola from the formula there. Curve line from origin with increasing gradient. Sorry, it should be from the origin. Two progressive wave, sound wave meet to form a stationary wave. The two waves have the same amplitude, wavelength, frequency, and speed. State the other condition that must be fulfilled by two waves in order for them to produce a stationary wave. Okay, what is the other condition?
Travel from opposite directions, or they must superpose.
Okay, they travel in opposite direction. Stationary wave is formed on a string.
So can I also write they superpose? They must superpose.
Say again, say again.
Can I also write they must superpose?
They must what?
Superpose. Superposition superpose.
No lah. Why you want to say superpose? If they are traveling in opposite direction, they will superpose with it. That is a
Yeah,
we are
but
using the principle of superposition.
but if I can write superpose also, right?
They will travel in opposite direction. So to get the resultant, we use the principle of superposition. No?
Oh,
Okay, a stationary wave is formed on a string that is stretched between 2 points A and B. Figure 5.1 shows a string at time t equals 0 when each point is at its maximum displacement. The distance AB is 0.8 meter. Period of the stationary wave is 0.016 seconds. On figure 5.1, sketch a line to show the position of the string when t equals 0.04 seconds. Label this line P. Yep. What should the line be?
first, okay, the first half of the wavelength and then half again. So it's like the first bottom one.
First quarter
First
lor.
bottom.
First quarter, so
Ah,
it will be horizontal
yeah,
lor.
yeah.
Yeah, that should be your answer. First quarter is a straight line, horizontal line, P. Then 0.24, 0.24 is complete one period already. So
Teacher, why
it's,
you draw another wave?
say again,
Why do you draw another wave?
that's Q, Q, okay now. Q is, the period is 0.016, so subtract there is half a period, lor. So half a period is this one is going up, lor. Okay now.
Oh,
This one going down, lor. Half a period, half a period, this will be down, lor. P is the blue line, lor. Horizontal.
oh, P is the blue line. Oh, okay, alright, I
P,
see.
you have two of them, one is P, one is Q.
Yeah.
Okay, any more queries?
No, but I don't understand what are they asking for.
They are asking in figure 5.1, sketch a solid line to show the position of the string at 0.04 second. Right? The string is vibrating, this part is vibrating upwards, come down, upwards, come down, go down, upwards, like that. So they want to know 0.04 second. 0.04 second is a quarter of the period. So it means that this is, if we start from here, it should be horizontal. Same like this one, start from here, it should be horizontal, a quarter of a period. Whereas 0.024, right, is one period and another half a period. So half a period will be this a quarter, then after that another quarter. Can or not?
But they said draw sketch a solid line. But you sketch
Don't
a
let
curve.
that confuse you. Is a line can be a curve.
Oh, serious. Oh, okay.
Okay, that is their their wording. They will always ask you to draw a line. They won't ask you to draw a curve. Okay, so keep that in mind.
Okay.
Keep that in mind. If not, you will get confused why they call it a line. Line will be a straight line, but no, line can be a curve. Any other
Alright.
queries? This is a marking
No.
scheme. Right, we got 8 more minutes.
Wait,
Determine
teacher,
the
what's the speed? 25.
speed of progressive wave along the string.
Okay.
Right, yeah, given 0.8 is the distance. Right, there's two wavelengths.
25.
Then speed is lambda over period. 25, correct. The vertical beam of polarized light of intensity I naught, as I naught polarized, is incident normally on the polarizing filter that has transmission axis 30 degrees to vertical as shown in figure 5.2. The transmitted light from the first polarizing filter has an intensity of I1. That's your I1. It's your I0. The light is then incident normally on the second polarizing filter that has a transmission axis at 90 degrees to the vertical. The transmission light from the second filter has an intensity I2. That's an intensity I2. You want to calculate the ratio of I1 to I2. So remember Mahler's law or law of Mahler's. We are working with this one. You are not interested in the unpolarized light. You are interested in only this part. Okay, so I naught, I1. So write the formula down.
0.75.
0.75. Ratio of
That was
I2 to I
0.
naught. Same. Use the same formula. This one we have calculated earlier. Now is part 2. I2 over I1. Right? Another 30 another right perpendicular is another 60 degrees. So 30 and then 60. And where we get 60? Can
Eh?
any comment or any query?
Oh, 60. I accidentally put 90.
No, because we have adjusted 30 already. So another 60 degrees to go perpendicular to the original direction. Okay,
Yeah. What was
define,
the answer again?
say again,
What was the answer? What was the answer just now?
0.919.
Yeah, yeah. Okay. All right. Yeah, I got it.
Okay, what is the define electric potential difference?
Energy transfer per coulomb of charge
Any
between
transfer per unit
2
charge
points.
from electrical to other forms.
Hey, teacher, my answer correct or not?
As long as you got energy transfer per unit charge, yeah, okay. Lor.
Don't need to say electrical form to other form.
They are not that strict, but the right one should be from electrical to other forms.
Oh,
So
that's if it's
they are not that
electric
strict.
potential difference.
As long as you got energy transfer per unit charge, yeah, okay. Lor.
Oh, that's for electric potential difference, right? What if it's just potential difference only?
Electric potential difference is the same. Potential difference is electric potential difference.
Okay.
Usually you should qualify with electric potential difference because it can be gravitational potential difference. So they are
Oh
qualified.
yeah, that's true.
This electric potential difference. A battery is connected to two resistors X and Y as shown in figure 6.1. The resistor X is greater than the resistor Y. State and explain which resistor dissipate more power. Yep.
Teacher, I wrote if the current remains constant and the wires are symmetrical, resistor X will dissipate more power than resistor Y because power is directly proportional to resistance.
We are basically using this equation. I square R, I is constant for both of them, right? Same or equal current in X and Y. That's the first point, right? Rx is greater than Ry. Okay, that's an alternative answer.
Or a teacher, in what situation current will not be constant throughout the circuit?
So either you use current, this one, or use potential difference. No? Then after that, the final answer is so X dissipate more power. No?
Okay.
That's your second point. No? This one is either you use I square R or P equals to VI to present it out.
Teacher,
Yeah,
this one, how come the current is not constant? Huh?
the
Why
electromotive
is that?
force 9 volt, internal resistance R is connected to two resistors P and Q. The total charge move through the resistors. Anytime will be cut off lah. P is time interval is 5.4 seconds. During this time, the resistor R dissipate for 4,800 joule of energy. The current in Q is 4.5 ampere. Assuming that the EMF of the battery remains constant, they did not tell you P and Q are the same. Okay, so
Yeah.
they did not say you cannot assume. Can current can or not?
Yeah, teacher, but I thought current is always constant throughout the whole circuit. Huh?
Okay, potential